Today, I'm processing a large batch of junk gold-filled jewelry. In total, I have 657 grams. What makes this material special is that it's required at least to start at 5% gold by weight. That's not enough to sell as scrap jewelry, but it's fantastic for refining. So at 5% of 12 karat gold, or 657 grams, should yield us roughly 16.5 grams of pure gold. This process is hungry for chemicals, though. It's going to take us nearly 2.3 liters of nitric acid.
But for nearly half an ounce of pure gold, it's well worth it. So I've already removed all of the magnetic components that I could find in this material. But before we touch any chemicals, I'm going to have to clear out the invisible contaminants. This means burning off organics. Once there's no more smoke and everything is red hot, I'll transfer it into this beaker of distilled water. Along with burning off organics, I'm sorting through to pull out any pins or other pieces of iron I missed. I'll just put it into a cooler dish because the other one's too hot to touch. Help me sort it a little better, get everything out there and get it all into the beaker. I love using the ceramic insulation underneath, no heat at all. So we'll get the beaker up on the heat. We're going to add nitric acid. Gold-filled material is mostly brass under a thin gold skin. To dissolve that brass, we're going to end up using about 2.3 liters of nitric. However, if we add that all at once, we're guaranteed for a boil over. I'm going to start with just 500 milliliters at a time. And I'm going to do incremental adds until we get to about the halfway point. All right, about half of our nitric has been used. There's a few little gold foils floating in there. I'm going to go ahead and decant this off. And we're going to start filtering the solution. There's a lot of filtering involved in processing gold-filled material. So the sooner we started, the better. See our material, it's kind of a mess in there. We'll make that much cleaner by the time we're done. So we're going to set this aside, get filtering started. Then I'm going to restart our nitric boils with fresh distilled water and nitric acid. All right, so we're almost done with the nitric boils. I'm going to go ahead and decant this solution off so we can get it over to filtering. You can see our foils in here are much cleaner than the last time. We're just about done with the nitric. Our gold foils, although they're holding their shape, when I smush them here, you can see they are very thin, super pliable. I'll do one last sanity nitric boil, so I'm going to add distilled water, just about 100 milliliters of nitric. We'll let this go. The more base metals we take out, the better. And then over to our filtering. This has been going for several hours. We're filtering it, we're covering our silver chloride from it. This is what we're after. There's some gold foils in there. That purple mud you see is actually gold as well. So we're going to go ahead now and filter our last nitric boil. We're doing this separately because the nitric that comes out here is not fully used. So we're going to save that off for use in a separate refine later. I am putting this into a smaller beaker. There's one thing I do differently, is I'd have built my hood taller. So something to think about if you're building a hood. We're going to get this all into the filter, all of our foils. Going to let it filter through. We're going to rinse it with a little bit of distilled water. Okay, so it's been filtering for a bit. It's done. There's our material where our gold is. Going to go ahead and pour this into a container and save it. Again, this is usable dilute nitric acid. So we'll go ahead and label that and set it aside. Right. Gold-filled does have silver in it. This is our first decant with a little bit of silver chloride. This is our second decant with significantly more. We're going to go ahead and get that saved off into our temporary container for silver chloride. Once we get enough silver chloride from different refines, we'll go ahead and process that. This looks like a lot, but it's not. It's probably less than half an ounce of silver in there. We'll wait till that's a much more substantial amount before we do anything else with it. But we are going to keep it wet. That will help make anything we do with it later more efficient. Back to our gold. This material, we have a couple of steps to do before we start dissolving it. First, I'm going to go through and just make sure everything looks like gold foils in here. So there's this one chain that the nitric clearly didn't touch. It might be Karat Gold, it might not, but it's definitely not gold filled, so we're going to take that out. Next, I put it all up on the hot plate, and I let our filter papers burn up in here. This is a nice clean way of doing it. It doesn't blow any paper around with the torch. Then I re-incinerate everything back to red hot. This is going to oxidize any potential problem metals that might have followed through so far. Make sure that they stay out of solution when we go into Aqua Regia. I use a catch plate, which ensures that any little pieces that do blow out don't go very far. We'll get those back into the container, and then we'll see where we're at. So we started with 657 grams of gold filled material. After our incinerations and nitric boils, we're down to 35 grams of material left. This is our gold rich material that we'll now put into Aqua Regia. For Aqua Regia, we're going to start with hydrochloric acid, a couple hundred milliliters. Not a ton here, just enough to get going. And then we're going to add a couple of milliliters, maybe 2, of concentrated sulfuric acid. This will drop out any lead. And then I'm going to start with about 8 to 10 milliliters of nitric acid, and then we'll do incremental adds of nitric acid until additions stop reacting. This will prevent us from having excess nitric that we have to take care of later. All of our gold and other metals have gone into solution. It's kind of an ugly, dirty solution, but we'll do a quick stannous chloride test. And that dark stain means that we have good gold. I'm adding ice as this will cause any silver chloride that's come through, or silver that's come through the drop is silver chloride, so we can filter it out of solution. Because as with all gold-filled material, all refined really, but especially gold-filled material, it's time for a lot more filtering. Although I'm going to speed it up. This first filtration is going to be very slow. There's a lot of solids and junk floating around in there that we want to get rid of on the first pass through. First filtration is done. We're going to go ahead and pull off this funnel. See all that junk that was in there? The solution itself is still quite cloudy. We're going to try to get this clearer, but to do so, we're going to start with the new filter paper. It will take forever to filter through that old one and may pull some of that stuff into our solution. So we're going to start here and just keep repeating filtration until we get our solution as clear as possible. Alright, so I have filtered this about 10 times. And while it's clear, it's still not perfect. But at this point, I'm making a decision. The solution is growing faster from rinsing out of the beakers than it's clearing up. So I'm going to make the call, and we're going to go ahead and drop this gold that I'm showing on that stannous out of solution. I'm using SMB. This is Stump Out by Bonide. You can get it at Home Depot. I'm expecting about a ½ ounce of gold, so I'm going to start with 2 spoonfuls. Do a quick stannous chloride test and see if we've got all the gold out of solution. And we clearly do not, so we're going to add a spoonful of time and test until we come back negative. This stannous test shows all of our gold is out of solution. I'm going to go ahead and cover this, and we're going to let it settle. So I've let the gold settle overnight. It's all on the bottom of the beaker here. So I'm going to go ahead and decant off the waste solution. They're going to rinse it with distilled water a couple of times. Decant that into my temporary stock pot. Now I'm just transferring this to a smaller beaker before I go into a hydrochloric acid boil. Just a little less volume to have to worry about. So for the hydrochloric acid boil, just going to add probably about 100-150 milliliters of hydrochloric acid. Put this on the heat and let it go for about 10 minutes. Once I decant off the acid, I'm going to do several washes with boiling distilled water to clean up that powder, and we'll take a look what it looks like. So for this gold, I've decided to do one more boil in hydrochloric acid. I'm going to follow this with more boiling distilled water washes. See if we can clean it up just a little bit more. Finally, I'm going to transfer it to an even smaller beaker and put it up on the warm hot plate. Not hot, but warm to dry. Then we're going to melt this up and see what we did. Put the gold powder into the melt dish. We'll hit it with the torch. And there's our nice size looking gold button. Get this quenched and we'll see what we have. Okay, so let's look at the numbers. We started with 657 grams, expecting 16.42 grams of gold. I did remove this 10 gram 14 karat, did turn out to be 14 karat gold chain, so happy about that, from the mix, leaving us with 646 grams. And so from that, expecting a 2.5% yield of 24 karat gold, we expect just over 16 grams of gold still, 16.16 to be exact. Here's our button. It's not completely pure, but it's actually pretty pure, probably 95-97% pure. We'll have to re-refine it for sure. But let's see what we got. So we are coming in at 15.96 grams. That's pretty close. Not bad for a pile of junk jewelry. All right, well, that concludes this video. I hope you enjoyed it. Thanks for watching. Please like and subscribe. As always, please share your own experiences, feedback, suggestions, or questions in the comments below.